guys, welcome to Kweku Online Study. So today I want us to talk about A-level maths, okay, quadratics. I think that's the first topic that we do there. And I've compiled this worksheet purposefully to help us to know how to answer A-level maths questions and then also score good grades when it comes to quadratics, okay? So we will start with the first question. Most of these questions, basically look like add maths questions, all right? The only difference here is that some of the questions would just require you to think a little bit. That's it. But the rest, basically, if you did add maths, you should be comfortable here. All right. So the first question says that the curve with this equation, let's choose a desirable pen. With this equation, and then there's another straight line here, okay, we should find the values of C for which the curve and the line intersect at two distant points. That's the most important thing. When two curves or two lines or a line and a curve are intersecting and we are told that we have two distinct points, we use this discriminant to make our argument, okay, that b squared minus 4ac is definitely going to be greater than 0. Now, since they actually met, what we want to do is to equate our two y values, okay. So we are going to equate the quadratic to the linear, okay, and then we are going to have this plus 2cx minus 4x plus 4 minus c, okay, sorry, minus c is equal to 0. So that we can have x squared plus 2c minus 4 or x into brackets 4 minus c. All right, and then we apply the discriminant on it so that we can have 2c minus 4 all squared minus 4a, and then c is greater than 0. Okay, so once we do this, we can expand. And then when we expand, we are going to have plus 16. And then this is negative 16 plus 4c is greater than 0. So these two will definitely cancel out. And then we are going to have 4c squared minus 4c is greater than 0. So we can pull out 4c. And then we have this minus, I think minus, hold on. This was, this should have been 16, I believe, 16, because times 2 times 4, that's like 8, times 2, that's like 16. So this part will become negative 12. So when we factor out, we can have a 3 here is greater than 0, okay? Then we can say that, well, our critical values are going to be critical values. That's when you solve this particular equation, equate it to 0 to solve, you are going to have c equals 0 or c equals 3. Okay, and now I want you to come back here to this particular quadratic and sketch it. All right, it's having a positive coefficient for the c square. So the quadratic is going to look like this. And then put your 0 on it, put your 3 on it. They say the quadratic is greater than 0, so we are interested in the part that is above the x-axis. And for this part, we expect that our c should be less than 0 or c should be greater than 3, okay? And then you are done. So like I said, this mimics what you did in add maths, but then, 5 cool marks, okay? Now let's look at this question. It says that we should use a suitable substitution to solve this. Now, I would probably say that let u be equal to 2x minus 3 all square. Someone can say that let u be equal to 2x minus 3, just that. But then I took everything because I think it's the best way to go, in my opinion, though. So you have u minus 4 over u minus 3 is equal to 0. so that I can have u squared minus 4 minus 3u is equal to 0. And then you can rearrange it well so that you could factorize it. All right, and when we factorize it, we are going to get u minus 4 and then u plus 1 is equal to 0. So u is equal to 4 or u is equal to negative 1. All right, but then we know that this is what u is. So we can say this is equal to 4 or this same thing is equal to negative 1. Right. The point is this has no real solution, because you are going to take the square root of negative 1, which does not exist for real numbers. You're going to get complex numbers. So we can just assume that there's no real solution and move on to this one. This one, you would take the root of 4, that would be plus or minus 2, and then we can take the 3 to the other side, so we have 3 plus or minus 2, so we can have 2x equals 5 or 2x equals 1, so that x is either 5 on 2 or x will be half. Okay, and then you are done solving this for 4 marks, beautifully like that. Okay, what if you are given something like this? All right, so when you have this expression, basically they want you to complete the square in a beautiful way. So that's exactly what we are going to do. Of course, I know some students might say that, why don't we expand this and compare with this and then just go away? Well, that's also another approach. Okay, I know you would probably do that, which is fine. But I want to use another approach so that you have more, strategies on how to go about questions, okay? So I'm rather going to take the long way, but then I believe it's a way that will just increase your knowledge in maths. That's why I'm doing it. If not, then better expand it, compare the coefficients, and then solve for A and B. All right, so first I'll factor 16 out so that I have x squared minus 3 over 2x plus 5 over 8. Basically, the 3 over 2 is the same as 24 over 16. I didn't want to write in huge numbers. Okay, then I'm going to take half of the x term, coefficient of the x term. So that will be 3 over 4. I'll square it and subtract that. I believe you remember this trick from AddMath, how to complete the square. Okay, then I'm going to have, I'm going to combine the first 3. Okay, the first 3. So that should be x minus 3 over 4 all square. We just use the first and the last in doing this. And then you put the remaining on the calculator. Maybe that's the best thing you want to do. All this, you want to put it on the calculator so that you don't make any mistake. And when you put that on the calculator, it will tell you 1 out of 16. And then use the 16 outside to multiply. So I have 16 into brackets x minus 3 over 4 all square plus 1, okay? Now you want the 16 to go inside a bracket, but then that bracket is square. So before the 16 can go there, it goes into that bracket as a square root of that 16. So square root of 16 is 4. So you have 4x, okay? And then use that to multiply the negative 3 over 4. That comes negative 3 plus 1. You are good to go. Now, if you choose to go the other approach I was talking about, that is, you expanding this, that should give you 16x squared plus 8xa plus a squared plus b. All right, so 8a is actually equal to negative 24. That's if you compare the coefficients. Okay, so a is negative 3, just like the way we got the negative 3 there. And now if you want the b, a squared plus b is the constant, and that's 10. So you have negative 3 squared plus b equals 10, which is 9, right? So this is minus 9, b is 1, just like the way we also got the 1 there. So like I said, any is fine. I just wanted to show you the method on the left hand side, okay? All right, then we are told that given that this, okay, given that this equation, where k is a constant has exactly one root. Find the value of this root. Okay. Now, you need to understand one thing, that there are two ways to solve this particular question. You can either go 16x squared minus 24x plus 10, okay, minus k is equal to 0. All right. And then you say that, well, since it has only one solution, then this is tangent. So the discriminant is going to be like this. All right. And then you can do your 24 square minus 4 into a into c, which is equal to 0. Okay. And then this will give you 576 minus 640 plus 64, k is equal to 0. And then this will mean that 64k is equal to 64. So k is equal to 1. So you found the value of k. All right, but then, I mean, the question isn't really about find the value of k. Only they wanted the root, that the x component at where it occurs. So if you know the value of k, you can move on to find, actually put k there to solve for x, and you're good to go. But then that's too long. So what I want you to do, because they made you find the a part for a reason. So if you have 4x minus 3 all square plus 1, remember, if you should sketch this quadratic, really, the quadratic is going to be like something like this. Okay, that the turning point is something like this. This is 3 on 4. I'll explain later on. And then this is 1. Okay, so suppose that this is the case. If you want one solution, then that line should be touching the curve at that turning point. Okay, so really the value of k is at that y value, okay, where y is equal to 1. All right. And then this occurs when the inside bracket is equated to 0. So 4x minus 3 is equal to 0. And that means that x is equal to 3 over 4. That's why we know that the root happens at x is equal to 3 over 4. But then the value of k is 1. Whether you use this long process or you use a short process, the value of k is 1. All right, that brings us to the next question. That says that the equation of a curve, this and this line, is that the key word here is tangent. So if it's tangent, then you know that your discriminant is going to be equal to 0. So first equate them, make a nice quadratic, and then let's work with the discriminant. So we have 2k minus 3x all square minus kx minus into bracket k minus 2 is equal to 3x minus 4. So we have this, you don't need to expand it, and then, oh no, is the x, that's right, that's good. And then you can expand this one if you want to. But then I want to bring the 3x here, and then I can expand this definitely, and I'll bring the 4 there, equal to 0. All right, so that I can have 2k minus 3x squared plus into bracket negative k minus 3x out, and then plus into bracket negative k plus 6 equal to 0. In this way, I can argue that negative k minus 3 all square, I'm using my discriminant, all square minus 4 into a into c is equal to 0. So that I can have k square plus 6k plus 9, negative 4 out. Let me expand the two brackets. So I have 2k, negative 2k square. And then I have plus 12k. Then I have plus 3k minus 18 equal to 0. So I can simplify what is in that bracket. So I have negative 2k squared plus 15k minus 18 equal to 0. So I can use that 4 to multiply or open up that bracket. Okay, and that's 60k. Actually, that should be negative 60. And then plus 72 equal to 0. So I'm going to have 9k squared, and I'm going to have minus 54k, and then 9 plus 72, that's 81. So plus 81 is equal to 0. All right, then you can divide 3 by 9 so that you have something really simple to work with. Should you factorize this, you are going to get k minus 3 and k minus 3. So k is definitely equal to 3. All right, they knew you get one value of k. That's why they said find the value of k. If you would have gotten more than one, they would have stated that find the values of k. All right, so you do this for 5 marks. You just have to be really, really, meticulous about your work with your expansion and things like that. If not, you might make a mistake. All right, the next is, this line is tangent to this curve. Now find the possible values of m, and then you find the corresponding coordinate at which they touch the line. So something like this isn't in ADMAS. This is purely an A-level question. You understand? And it starts just like the ADMAS, nothing fishy until we are about to complete, and that's where all those interesting things will come in. So once it's tangent, then we know that the discriminant is equal to 0, but then we just have to equate them first and then work out the answer. So we have this minus 4x minus mx plus 3 plus 6 is equal to 0, so that we can have x squared plus into bracket negative 4 minus mx plus 9 is equal to 0. So once we have this, we can argue that our discriminant must be equal to 0. And that will give us negative 4m squared minus 4 into a into c is equal to 0. So this will be 16 plus 8m plus m squared minus 36 is equal to 0, which will be m squared plus 8m minus 20 is equal to 0. You factorize this, get m plus 10 and then m minus 2 is equal to 0. So your m is negative 10 or m is 2. Right, one of the instructions was that find the possible values of m, and that's exactly what we've done. We found the possible values of m. So now we move on to the other side of the question that said that we should look for the corresponding coordinate for which the line touches the curve. So, and that's exactly what we are going to do. All right, now let's start by saying that for m is equal to negative 10, well, if that is the case, how would you find the x coordinate? Well, just come up a little. Let's take this equation right here. It will change a little. This equation right here, if m is negative 10, the whole of this will change a little, and that's what we are going to work on. We're going to put m there. I don't want you to put m from the beginning. Okay, just put it there, so that if m is negative 10, that part will be, think about it, you have negative 4 minus 10 x plus 9 because so definitely you are going to get x squared plus 6x plus 9 is equal to 0. And this is definitely x plus 3 is equal to 0. So x is definitely 3, negative 3. And now if you want your y, probably put it into the easier y to work with, because m is already negative 10. X is negative 3 plus minus 6. So that's 30 minus 6, that's 24. So one of the point that they intersect is negative 3, 4. The other point will be 4. M is equal to 2. Well, if m is equal to 2, then we will have x squared plus negative 4 minus 2x plus 9 equals 0, which should give us x squared minus 6x plus 9 is equal to 0. And now, when you factorize this, you should get x minus 3 and then x minus 3 is equal to 0. So x is definitely going to be 3. All right, so we can put it into that mx minus 6. We know m is 2, x is 3 minus 6, y is 0. So the other point is 3, 0. That's it. Okay. So like I said, the red part of the work is what the A-level knowledge comes in. Okay, because now you have your add mass covered. So the little part is that use the m values to get a new quadratic, solve to get the x values, put it into one of the y value, the curves, either the curve or the straight line, to get a corresponding y value. But you have to do it twice because obviously the circle, was it even a circle? The quadratic and the line were meeting at 2 points. This point, oh come on, this point, and then why is this thing behaving like that? Yeah, and that point. Okay, all right, let's move on. We see more questions like that though. All right, now we are told that we should find the set of values for which they do not what intersect at all. Well, if that is the case, then you should know that you'll be working with a discriminant like this because they do not intersect. All right, so this same process, nothing really serious. Okay, for this question, an add math student should be able to do it. All right, there's nothing screaming A-level about this question at all. But maybe we have forgotten. That's why Kweku Online Study is there to remind us. Okay, so you can factor the x out, and then we have, let me just write 2 minus k. It looks beautiful that way, so that we can have our b squared minus 4 into a into c equal to 0. Oh, sorry, it's less than 0. They do not meet, less than 0. All right, and that will be 4 minus 4k plus k squared, and then minus 8k plus, I think that should be 4k squared, right? It's less than that. I hope this thing is correct. So I have 5k squared, and then I can have negative 12k, then I have 4, it's less than 0. And then when we factorize, we should have 5k minus 2, and then k minus 2 is less than 0. Then we look for the critical values. All right, this is quadratic inequality, so this is how we solve it. The critical values are, we have k is equal to 2 over 5, or k is equal to 2. Now, I want you to sketch it. You sketch it based on the new quadratic you have. As you can see, it's a positive curve, so it's a U shape. And this is 2 on 5, and this is 2. They said it's less than 0. That means that all the parts below the x-axis, so we are just working right here. All right, and if that is the case, then your k is in between 2 on 5 and 2, and you are done. Okay, nicely for 5 marks. All right, the next thing is that this is quite A-level. I'm not going to lie, like really A-level, because you have a circle, all right, and a line, and they're going to intersect at 2 points, but then they want you to leave your answer in the set form. After that, given that you now know the coordinates of A and B, use it to find the exact length of line AB, of the chord AB. Anyways, so what you basically have to do is to put this one right there. So the x squared is there. For the y, we know y is 2x plus 5. And the reason we are doing that is they said they they intersect. So if they intersect, we can solve them simultaneously. It's equal to 20. So we have this 4x squared plus that's is 20x plus 25 equals 20. So we have 5x squared plus 20x minus 5 equals 0. So you can have x squared plus 4x minus 1 is equal to 0. So we have, oh, it's actually plus 5. So plus 1. Okay. Once they said in the set form, you are going to use the quadratic formula that x is equal to negative b plus or minus the root of b squared minus 4ac all over 2a. You're going to use this formula. But I'm not going to do that. I'm just going to use calculator to solve it. And I'm going to do that because I'm not in exam room. But then you can't afford to do that in exam room. You really have to go through to do it to gain all your necessary marks. All right. Now, if this is the case, then we need to put it into one of the y's to find the corresponding y value. And I'm going to put it in the first y because it's easier to work that way. It's 2x. So 2 times my x and then, plus 5. All right. And that is going to give me y is equal to negative 4, 2 root 3 plus 5, which is basically 1 plus 2 root 3. Okay. And then, so that point is negative 2 plus root 3, comma, 1 plus 2 root 3. You are done. The next one is going to be y is equal to 2 times x, which is this. Yep, plus 5. You expand, you get negative 4 minus 2 root 3 plus 5, giving us 1 minus 2 root 3. So our point there is going to be negative 2 minus this, comma, and then 1 minus 2 root 3. You may be wondering, so which one is our A, which one is our B? Well, doesn't matter. Don't even, label anything. Just leave it like that. So if we are looking for the point AB, the line AB, you are going to have your difference. You remember this formula? Root of x1 minus x2 all square plus y1 minus y2 all square. Yeah, that's the length formula. So that's exactly what I'm going to use. So I have already squared my AB so that I don't have to take the square root for now. So I have negative 2 minus root 3 minus, and I have my negative 2 plus root 3 all square plus my change in y, which is 1 minus 2 root 3, and then I have 1 plus 2 root 3 all square. Okay, so that I can have negative 2 minus root 3, okay, and then I can have plus 2 minus root 3 all square. Then I'm going to have 1 minus 2 root 3 minus 1 minus 2 root 3 all square. And then the 2's will cancel out, so I just have negative 2 root 3 all square. Then here the 1's will cancel out, so I have negative 4 root 3 all square. That ensures that I have 4 into 3, and then I have 16 into 3. And this should give me 60. So I know that my AB square is 60. So if I want AB, I just take the square root of 60. So I can either leave it like this, or I can say that this is the same as 2 root 15, and I'm done. All right, simple as that. And this should give you how many marks? 7 solid marks, friends. 7 solid marks. All right, so when you see a question like that, don't panic. Note that we've done some before, so you should be okay. All right, now the next thing is we look at the B part of the question that says that a straight line passes through this point with this gradient and is tangent to the curve, so find the possible values of m. Well, listen, the straight line that they have given us a lot of information about. Okay, every straight line is of the form, this is the general form of a straight line, y equals mx plus c. So if the gradient is m and is passing through this point, so x is 10, So we know that C is going to be negative 10m. All right, we know this already. So that straight line they are describing is going to be mx minus 10m, which you may choose to factor m out, so you clean it up a little. So you have something like this. So this is a straight line. They are saying that it's tangent to the circle. That means that they actually met. And if they met, you just have to solve them simultaneously. The circle itself is x squared plus y squared equals 20. So I know that the circle is x squared plus y squared equals 20. So my new y is my m into bracket x minus 10. So I'm going to put it right there. So I have m into bracket x minus 10 all square is equal to 20. So I have x squared m squared x minus 10 all square is equal to 20. So I can have x squared plus m squared into bracket x squared minus 20x plus 100 is equal to 20. So I can also have x squared plus mx squared minus 20m squared x plus 100m squared minus 20 equals 0. So I'm going to have 1 plus m all square, not all square, sorry. That's 1 plus m x square. Then I have negative 20m square x. Then I have this as my constant. Since they said that it is tangent, okay, this is a key word, it's tangent, we are going to use the discriminant on it. So we have b squared minus 4ac is equal to 0. So this is my b squared minus 4 into a into, oh, this m is actually square. Sorry about that. Into 100m squared minus 20 equals 0. Okay. And now we're going to have 400m squared minus into bracket. Let me expand those two brackets so I can have 100m squared minus 20 and then 100m to the fourth power minus 20m squared. We can simplify what's in that bracket so that we get 100m to the fourth power plus 80m squared minus 20 equals 0. So that we can use the 4 finally to expand it, and we will get something beautiful like this. Okay, so these two will cancel out, obviously. Hold on, this is actually b squared, so why didn't I square that part? So that this becomes a fourth power. Okay, so I'm going to have 320m squared is equal to 80. Okay, and that means that m squared is equal to 1 over 4. M is going to be plus or minus the square root of 1 over 4, which is half. Okay, so these are your two values of half of the m. Okay, how many marks for that? That's 5 marks. Good. So that's how you solve such a question. Generate the new the new line, solve it simultaneously with a curve, and you are good to go. You can also use differentiation to solve this same question, but then we are doing quadratics, so I don't want to branch into that. Okay. If you want to use differentiation to do it, then you should understand that the gradient of the circle will be equal to the gradient of the line, which is m. You equate them and you solve. You should be fine. Okay. Yeah, that reminds me. Actually, don't even try to do it, because there is an aspect of differentiation A level called implicit differentiation. You study this in P3. You need this knowledge to differentiate this circle because the y is square. All that you know how to differentiate is when the y is not square. Now y is square, so you need a knowledge from that to do it. So don't even bother doing it. Okay. Now we are told that the equation is tangent to the curve. Why should we do this? Coordinates of the vertex. Yeah, probably. yeah, probably we don't have to do this one because we've done so many questions on this. So what we rather do is that we pay attention to what this is. They are telling us that now k is 2. So what does it do? Well, the line, the curve, the quadratic is 2x squared. So 2x squared, but then we have kx. So k is 2, so we have 2x. And then we have k minus 1, right? So we just have 2 minus 1. So that means that our quadratic simplifies to this plus 1, basically. And they want us to work with this and then talk about a vertex. I've not done a question on it, that's why I'm doing it. So we can factor 2 out. So we have this, that, and a half. Take half of the coefficients of the x term. Okay, so that means that we have plus half all square minus half all square plus half. All right, take the first 3, so that I have x plus half all square, and then you simplify this one, probably with the help of a calculator to be the best, because you might make a mistake, which is 1/4. Use the 2 to multiply out. You have this, and then you have plus half. Okay, so they want the vertex. All right, now the vertex is basically the turning point of this quadratic. It will turn at, so vertex, when you equate whatever is in the bracket to 0, that will be the x coordinate, and that should be -half. And then this value right here, oh, come on, why behaving like that? This value right here is the y component of the turning point. So you have -half. That is the vertex. All right, so okay, so this is a good question that we need to do because of what the m and these are. Okay, so we are told that let's use a bright color. They are tangent, so just we solve it. So we have x, y equals 16. Let's dump this y right here. So we have x into mx plus c equals 16. So you have mx squared plus cx minus 16 equals 0. So this is what we have. But then they said it's tangent, so the discriminant must be equal to 0. And then that means that we have c squared minus 4 into a into c. Okay, they said that express m in terms of c, so make m the subject. So we have this, we have plus 64m equals 0. So 64m equals -c squared. So m is equal to -c squared over 64. And then you have your 3 marks. Okay, cool, chop. The next thing that you want to do is, they said, okay, we've changed the m. So we'll find a set of values for c, for which the line intersect the curve at 2 distinct points. They have changed the parameters, so be careful. Okay, now you had what is it? You had something like this, and you work with it. But now they have changed m, so go and change the value of m there. M is -4, so that means you have -4x squared plus cx minus 16 is equal to 0. Also remember that they said that 2 points, 2 distinct points, that means that the discriminant changes a little to this. So we have c squared minus 4 into a into c is greater than 0. So this will actually be 256 greater than 0. 256 is the square root of 16. So we have difference of 2 squares here. Maybe you didn't see it coming, but then with practice, you see some of these things from a mile apart. So the critical values, are c equals -16 or c equals 16. You need to sketch this to do it well. The reason why it's positive is that the c itself that we are working with has a positive coefficient. So we know that its quadratic is positive. That's negative 16, 16. They want the part that is above the x-axis. So that means that c is less than negative 16 or c is more than 16, and you are done. Okay. So with such a question, when they change the m, go back, modify things before you continue working. Okay. Then we are told that you have a nice quadratic. We should get it in this form. Why will we do this question? Anything interesting? Solve for this. Okay. So I find it interesting. So first we would, work on this. Take half of 4. That's negative 2 square. Let me subtract. Square plus 8. So that will be x minus 2 all square and plus 4, basically. All right, so we have it nicely like that. And then they said that hence, that means that use whatever you have to work. Hence, find the value of this. Well, we know that our quadratic was this plus that is less than 9. So there are 2 ways. You can expand it and then, solve it, kind of long process, or you can also just, move the 4 to the other side to have 5, sorry, and then you take the square root of that 5, which would be basically plus or minus root 5, right? And then you solve this using your knowledge of quadratic inequalities, where you put whatever you have in the middle. You put a negative root 5 here, you put a positive root 5 there, and then you move the 2 to both sides. So you have 2 minus root 5 x, and then 2, plus root 5 x, and then you are done. All right. If not, then going to expand the quadratic and then find the critical values, sketch it, and then get the correct region, and you are done. Okay. So basically, this worksheet comprises of every possible quadratic question that they might even ask you, and that's what we've gone through. So I hope you have understood it. I've refreshed your memory of some add math tricks. Okay. Sub to the channel would be great, and see you in the next video. Okay, bye for now.